Hello students, I am Dr. Sunita Barve from National Chemical Laboratory Pune. Today I am going to talk to you on a module, Querying of the Information Retrieval System, which is part of topic Information Storage and Retrieval. The module will cover introduction, sets and subsets, relational statements, Boolean query logic, ranked and fuzzy sets, similarity measures and query processing. In an information retrieval system, it is a system that is capable of storage, retrieval and maintenance of information. Information search and retrieval involves finding out useful documents from a large store of information. In any information search and retrieval system, an important factor which plays a main role is search and selection process. IRS allows to find useful documents from a large volume of information by giving a query. An IRS consists of a software program that facilitates a user in finding the information the user needs. What is a query? Query in general terms is a statement or series of statements made by a user to a retrieval system for the purpose of specifying what information is to be retrieved and in what form. Query language, most of the time the query is specified in format such as artificial language, hence it is called query language. A query language tells the IRS what to do and what is wanted. There are two broad types of query language, procedural and non-procedural, or it is also called as descriptive query language. A procedural language involves the use of commands. It is much like a traditional computer programming language. The user makes imperative statements such as select and the record meeting certain criteria, then print and again certain records from a designated set of the database, or log off from the current online session and break the communication link once the query is executed. A non-procedural language is used to tell the IRS what result is wanted and the IRS then works out how to produce it. The same information is conveyed as with a command or procedural language, but imperative verbs are not used in non-procedural language and often the IRS prompts the user. What subject should be selected, in what order should records be displayed, etc. The same information is conveyed as with a command or procedural language, but imperative verbs are not used in non-procedural language and often the IRS prompts the user with what subject should be selected, in what order should records be displayed, etc. If the query is submitted in a natural language, IRS system has to use lot of context dependent logic to translate natural language into machine readable format, which is also called as the command language. For natural language queries, intermediator is required to formulate a query, as these queries generally tend to be ambiguous in syntax. On the other hand, command language queries are more structured and for IRS, these queries are easy to understand. After submitting a query to the IRS, any IRS sends back certain information to a user about the progress of a search as well as how many records were found meeting the criteria added in the query. On the basis of this information, the user then decides if any query needs to be modified further or to start search entirely again or to stop with whatever is retrieved by the IRS system. Successful queries retrieve the information wanted with only a tolerable amount of unwanted information with a reasonable cost in time and effort involved. Let us look at the documents in any IRS system. In IRS, query is distinct from the types of document that the user is trying to retrieve. The number of documents available in any IRS system and the query undergo generally parallel processes. On the document side, system generates or gathers some data and formulates it into a document. After creating documents, they are transferred into internal representation, which then gets transferred into a format that is used for matching process. Now let us look at graphical query format. Some descriptive languages use a graphic format for submitting queries. The user fills in values in a table. The placement of these values conveys the logic, and the whole then becomes a form of graphic representation of the search query. Here is an example of a graphic query representation or concept map. The query represented is for a search on earthquake resistant construction technique used in California with a date restriction. There are three subject facets in this query, and one for the concept is earthquakes, one for construction and one for California. Then there is also a date facet in the query. Technique is not the sort of term that help much in the query because an article on a new building material or method of constructions may never mention the word technique, while it will likely appear in articles on countless unrelated topics. The date facet simply shows a range of acceptable publication dates, maybe for example 1990 to 1999. So in a graphical format query, it is allowed to be presented in drop-down menu based where user has freedom to select terms based on the choices available. Language or user interface are often referred to as menu based. This means that a list of options is presented to the user who selects one or more rather than typing the entire value indicated. Selection can be by moving a cursor to the choice and double clicking a mouse button, striking one key or typing the number or first letter of the choice. This method saves much typing time and probably eliminates many typographical errors. It is of course still possible to make the wrong selection in the query. Hence, clearly the menu method is useful only when the number of choices is limited. Otherwise, users tend to get lost while formulating the query. Finally, the menu method is a means of entering information into a computer or conveying elements of a language. It is not really a type of language. Let us now look at sets and subsets. The design of most text-oriented retrieval systems until very recently anticipated frequent revision of the query statements and called the IRS to create a set for each query or even for each attribute value specification or Boolean combination within the query. Each such set represented a subset of the database, but the word set is the common usage. A set is well-defined collection of objects. In the retrieval system, set is a list of identifying accession numbers of the retrieved records satisfying the query. The user is informed only of the set number assigned by the IRS and the number of records found in the set after search is carried out. A set with no number is generally termed as a null set. To modify the search, one has to modify a query statement and carry out new search, and new sets are generated by the system then. Now let us look at relational statements. Relational statements specify the characteristics of records in a set to be formed or the characteristics of records that compose a subset of the database. Sets are defined by specifying one or more combination of an attribute, a relationship and a value. For example, attributes could be publication date equal to 2000, author could be cropped, or salary could be greater than 10,000. So unfortunately, a different meaning of relational is used than in the context of relational databases. Each record whose named attribute as a value conforming to the stated requirement is included has its number or pointer included in the set. So the basis is binary. The statement is either true or false, hence a record in the set or not. The list usually includes, now we can see here, equality is equal to subject maybe tennis. In inequality, date could be greater than or less than or not equal to. The not equal to is used in most computer languages. For example, chemical name contains ethyl. So in a record will be in the set if ethyl occurs anywhere in the chemical name attribute value. Then one more option with the available is range. Range could be 70,000 or less than salary or less than 1 lakh, a combination of inequalities. Now let us look at Boolean query logic. A user often thinks of a query in one of two forms, either as a question in everyday English or some other natural language, or as a list of terms. A query developed from a list of terms is called a Boolean algebra. Boolean algebra is historically first and still the most common method used for expressing a query statement. Boolean query involves specifying the operation to be performed on the query sets that have been defined by relationship statements as mentioned earlier. Boolean query is also based on concepts from logic with its terms joined together by logical connectives. Typically, the connectives permitted are, and, or, and not. These are sufficient together with grouping of terms to express any logical combination of terms. Boolean query also uses techniques such as by prefixing plus or hyphen operators with keywords. And let us look at Boolean queries in detail. A typical Boolean and logic query might be like library and information. One more Boolean logic can be used to bring documents from all Boolean operators such as digital and then combination of or operators such as library or information and management. The appropriate response with this query is to retrieve any document having the words digital, library, information, management. The appropriate response to this query is to retrieve any document having the words digital, library, information, management. In a Boolean query, the use of AND requires that both the terms be present in the retrieved documents. For example, if AND Boolean query is used, the set 1 may contain records with date greater than, say, greater than 2000, and the set 2 contains record with subject, it can be an example of tennis. Then if set 3 is defined as set 1 and set 2, it would contain records with both the desired date range and the desired subject. This is called the logical product, intersection or conjunction of the first two sets. Now let us look at OR. The use of OR operator requires that at least one of the term be present in the search results. Given two sets, a third can be formed from records that are either the first or the second or both. This is written as set 1 or set 2 and is called logical sum, union or disjunction of the first two sets. OR operator is always used in the inclusive sense, meaning records that are in the set 1 or set 2 or both. Now let us look at the NOT operator. While and or are binary operators in the sense that their operations require at least two sets within the universe of discourse, NOT is a unary operator, meaning that it can be applied to a single set within the universe of discourse to specify all elements other than those in the set to which it is applied. If the single set is A, then not A is known as the complement of A. Normally, in a retrieval context, not is considered to mean and not and is treated as a binary operator. Thus, if records are wanted about Wimbledon but not about tennis, the logic is that set 1 is to contain records with Wimbledon and set 2 to contain records without tennis, and set 3 their intersection records containing Wimbledon but not tennis. Symbolically, set 3 is equal to set 1 and not set 2. Set 3 is called the logical difference of set 1 and 2. Now we have another operator also in the Boolean logic called as exclusive OR. Found only occasionally in operational systems, this operator forms a new set containing members that are in one set or another but not in both. It may be expressed as the union of two sets from which the intersection has been excluded. For example, S1 or S2, not S1 and S2. An example of its use might be a search for medical patients who are taking drug A or drug B, but not both. If allowed in a query language, this operator symbol can likely be XOR. The advantage of Boolean query logic are that it is easy to write interpretive programs for it and that the logic is crisp and decisive. Boolean query has few disadvantages as well, such as most people do not naturally think in Boolean terms, hence the logic seems artificial and it is sometimes difficult for users to express what they want or to understand what they get. There is another disadvantage is there is no good way to weigh terms for significance. Either a term is present or absent. Thus, the user has little control over how important a given term is to the query. The next advantage of Boolean logic is Boolean queries is in retrieval results can be wrong because of a misstated queries. User is free to construct a highly complex query that requires the development of many partial responses to be assembled into the final response to the query, which is also one of the disadvantage of Boolean query. The next disadvantage is technically the system should return all documents satisfying the query. This may, however, either be a very small number or a very large number. While executing a Boolean query, sorting the documents by the number of matching query terms provides a rough ranking of the documents. Boolean retrieval systems are highly popular and reasonable, effective because of its ease of use in IRS. Now let us look at ranked and fuzzy sets. Ranked means to assign each record a measure of the closeness of the record's content to the query or the extent to which the record matches the query. The purpose of ranking records is to acknowledge that there is uncertainty as to whether the query exactly expressed user needs or not. Some of the most common ways of achieving ranking of records are: 1. Weighted terms, in which membership in the set is not precisely defined. A user's query might include a weight for each term showing its relative importance. This method has apparent advantage of allowing users to express variations in the relative importance of terms used. Users would have to learn how to assign weights by experience. Next is word list. To avoid the requirement for the precision of weights, a user can simply be allowed to use a list of words as a query statement. In ranking, third option is ranking Boolean sets. Ranking is not the same as set formation, and there is no reason why ranking must be based on information contained in the command used to define the set. The point of ranking is to acknowledge that there is uncertainty as to whether the query exactly expresses the user needs. Now let us look at fuzzy sets. In case of fuzzy information retrieval, when a user cannot accurately tell whether a given document will meet the information need, this uncertainty is called of fuzzy evaluation of the document with respect to the query. The concept of fuzzy information retrieval allows for both fuzzy document evaluations and fuzzy queries. Now let us look at next point, similarity measures. Similarity is the key concept behind information storage and retrieval. The aim of IRS is to retrieve those documents whose contents are similar to the information needs of the user. If a user finds a bibliographic record on the desired subject and wants more, he or she can simply ask for more rather than reformulating the query. To aid in this process, catalogers and indexers try to organize the document collection so that similar documents are in some sense close together and can be retrieved as a group with little efforts while searching. Any document can be represented by a list of terms that occur in it. A common way to define document similarity is to relate it to the key terms that two documents have. In case of retrieval of records, number of co-occurring words serve as a measure of similarity between two texts. Precision of retrieval can be gained by considering the number in common and the number not in common. There are several ways to measure how similar two texts are. There are several ways to measure how similar two texts are. They all use the number of terms in common to the two texts, but other factors also play an important role, such as sizes of the documents involved, the number of terms not in common, and weights that may be assigned to the terms. The use of weights allow greater importance to be given to co-occurrence of highly weighted terms, but their use is highly subjective. A similarity measure is generally applied to pairs of documents or to a document and a query. Now let us look at query processing. Some of the kinds of queries that are usually allowed on information systems are keyword based, focus based, and subject based. In case of keyword based querying, in this querying technique, user provides one or more search query, that is, keywords on the search interface. This is the simplest query technique in hand to users if he or she does not have the knowledge of the subject. This type of keyword based querying is similar to querying on search engines when list is prepared based on information need of user for keywords appearing in the queries without any specific parameters. If a particular keyword does not have any matching concept in the database, then no description is displayed to the user for that particular keyword. If for user's particular keyword, one or more matching concept is found, then the concept description available in the database is processed and displayed to the user according to some relevancy ranking mechanism. When the users will get their search result, they will try to refine the query by using much more appropriate keywords. If some keywords matches more than one concept, then the content related to each concept is processed and displayed on the user's interface based on some mapping algorithms. The keywords which appear in the expansion of a query for every description of concepts are presented to the user, and user is also provided with the option to narrow down their search keyword from broad to narrow subject so that they can identify the relevant concepts in their query. Now let us look at querying by focus. In case of querying by focus, a user has at least the knowledge of subject related to the content that are required, and this prior knowledge user has gained from the stored content, which has been classified hierarchically in the collection of users' content. So, in this situation, it is always expected to have better idea of the latent content of the query termed by the user, because this is presented automatically using appropriate technique so as to satisfy the original requirement of the user that was not known previously due to the lack of knowledge about the exact search query keyword to represent that particular concept. Now let us look at querying on subject. Query based on subject is very common querying approach among the specialized group of users where topical intent of a query refers to the subject. In the faceted method of representing a content collection, subjects are subdivided further to distinct level like the facets. A specific subject from a pre-existing faceted classification is aimed to relate with a typical query on subject. For example, a query based on subject is: what are the contents on the effects of abiotic factors on coffee plants? And there are many possible focuses for the query of the concept subject, and that query could be explained as coffee plants, abiotic factors and effects. Thank you.